This is Priyanka Sutar, Assistant Professor of Gallup Institute of Pharmacy, and today I am going to discuss introduction part of Unit 4. That is the introduction of heterocyclic compound. So in this introduction part, we will get to know basic structures or basic heterocyclic structures, which we are going to learn in detail further in upcoming classes. So before we start with our discussion, I would like to tell you to use a pen and paper. As you know, that chemistry is learned best way using pen and paper. So during the course of this discussion, I'm going to give you some instructions. So you can pause the video and you can write the structure. So I will give some instruction. You can pause the video, write the structure accordingly. This way you will understand much better instead of just listening to the video. Okay, so I'll start. So I have categorized these heterocyclic compounds in basic 4 categories. First category is 5-membered aromatic heterocycle containing 2 heteroatoms. 6-membered aromatic heterocycle containing 2 heteroatoms. 6-membered aromatic heterocycle containing 1 heteroatom. And last category, benzo-fused heterocycle. So let's start with the first category of aromatic heterocycle, which contains 2 heteroatoms. So here is the first instruction. You should draw 5 structures of 5-membered ring. So you have to draw a ring which consists of 5 atoms, and it should be aromatic. Aromatic means what? Conjugate double bond and single bond, and it should contain 2 heteroatoms. Now aromatic means what? Conjugate double bond, single bond, and for this conjugate system the cycle should be even number, right? Cycle should contain even number of heteroatoms, but this is a 5-membered, so the arrangement will be single bond, double bond, single bond, double bond, and again single bond. So single bond and single bond will be adjacent to each other, so you have to draw first heteroatom in between that single bond. Okay, and whenever you write the structure of ring, you number it as a 1 2 3 4 5. Okay, and you have to draw such a 5 structure because we are going to learn 5 structures of this particular category. So as far as first structure is concerned, first structure is a 1,2-azole. OLE means what? It is 5-membered ring and it is unsaturated. Here I have told you, right? It is 5-membered ring, it is aromatic, and it contains heteroatom at first position and second position. So you can pause the video and write the structure. So it must be looking like this. So your first structure, initial part or skeleton part of your first structure. Now for first heteroatom of this heterocycle is nitrogen, because it is azole, right? Az means what? Aza means nitrogen. So you can write nitrogen over here. Particularly in this structure, second heteroatom is at second position because it is 1,2-azole, and the second heteroatom is nitrogen, that is a aza. So you can write nitrogen over here, write nitrogen over here. So you can pause the video and write the structure. Particularly this structure is called as a pyrazole, and it is a trivial name of this structure. Okay, it is 1,2-azole, 1,2-azole, 5-membered ring which is unsaturated. So let's have a look at a second structure, which is 5-membered ring aromatic with 2 heteroatom, and the second structure is 1,3 azole. So you can pause the video and write the structure. It must be looking like this, right? It is 5-membered ring which is aromatic, and it contains 2 heteroatom at first and third position. As this is a azole, obviously one of the heteroatom will be nitrogen, so you can write nitrogen over here. And in case of the second structure, second heteroatom is at third position. As I told you that it is 1,3 azole, so second heteroatom is at third position and second heteroatom is nitrogen. Okay, so you can pause the video and you can write the structure. And name of this particular structure is imidazole. Again, this is a trivial name, it is not systematic name, it is a trivial name, and this trivial name can be used in systemic structure also. So it is a 1,3 azole. Okay, 1,3 azole, which is a 5-membered ring containing 2 heteroatom at 1,3 position, and 5-membered ring is what? Unsaturated. Now let's have a look at third heterocycle. It is a 5-membered ring which is aromatic and which contains 2 heteroatom. Both the heteroatoms are at first and third position. Pause the video and write the structure. So it must be looking like this, right? 1,3, and as it is azole, obviously one of the atom must be nitrogen, so one of the heteroatom is nitrogen. And in case of particularly this structure, second heteroatom is at third position because it is 1,3 azole and second heteroatom is sulfur. Okay, so nitrogen over here and sulfur over here. So you can stop the video or you can pause the video and you can write the structure. Particularly this structure is called as a thiazole. This is a systematic name. From name itself you can get to know what are the contents of the structure. OLE means what? 5-membered ring which is unsaturated. Az means what? It contains nitrogen. Thia means what? It contains sulfur. So thia containing sulfur, Az means containing nitrogen, OLE means it is a 5-membered unsaturated ring. So it is a thiazole. Okay, thiazole. So it is a 5-membered ring unsaturated. OLE contains sulfur. Thia contains nitrogen. Aza. Okay, thiazole. Moving on to the next structure. Draw 5-membered ring which is aromatic with 2 heteroatoms, and heteroatoms are at first and third position. Pause the video and write down the structure. So this is the structure of 1,3 heteroatom. Because it is azole, first heteroatom is nitrogen, and in case of particularly this structure which you are going to see, the second heteroatom is at third position because it is 1,3 azole, right? So on third position the heteroatom is oxygen. Okay, so nitrogen over here and oxygen over here. You can pause the video and you can write the structure. Particularly this structure is called as a oxazole. It contains oxygen, it contains nitrogen, and it is 5-membered ring which is unsaturated. It is oxazole. Oxazole is what? 1,3, 1, 2, 3, 1, 3 azole. Next structure is again 5-membered ring, which is aromatic, and it contains 2 heteroatoms. And this fifth structure is 1,2 azole. So heteroatom is at first and second atom of 5-membered ring. So you can pause the video and write down the structure. So it must be looking like this, right? So because this is azole, one of the heteroatom is nitrogen obviously, but this heteroatom, this particular heterocycle consists of a oxygen at first position. So you draw the ring and number it 1, 2, 3, 4, 5. At first position you write the oxygen, O for oxygen, and the second heteroatom is at the second position, and obviously it is a nitrogen because it is azole, right? So 1, 2 azole. Now if you have seen all the structure consists of a nitrogen at first carbon, whereas in case of this new structure, nitrogen is at second position, whereas oxygen is at first position. Okay, so particularly this structure is called as a isoxazole. Okay, so this is a isoxazole where nitrogen is not at the first position, it is at the second position. So it is a isoxazole, whereas you can see oxazole it is 1, 3 azole, isoxazole is 1, 2 azole. Okay, now we have learned 5-membered aromatic heterocycle which contains 2 heteroatom. Moving on to the next category, that is a 6-membered aromatic heterocycle. Okay, so draw 6 membered ring which is aromatic with 2 heteroatoms. You can pause the video and write the structure. Okay, and one of the heteroatom is nitrogen. In case of this structure, the second heteroatom is at third position. So first heteroatom is nitrogen and second heteroatom is at third position, and second heteroatom is again nitrogen. Okay, so it is what? It is a pyrimidine. Pyrimidine is a 6-membered, sorry, this is a mistake, it is a 6-membered ring with 2 heteroatom, and particularly this structure is aromatic. And pyrimidine is again trivial name, it is not a systematic name. This name can be used in the Hans Wittmann system of nomenclaturing, and you can see this is 1, 3 azine. Okay, 1, 3 because one heteroatom is at the 1 and 3rd position. It contains nitrogen and it is 6-membered ring which is aromatic, which is unsaturated, and structure look like this, that is a 1, 3 azine. Now moving on to the next category, 6-membered aromatic heterocycle which contains 1 heteroatom. This is very simple, right? You just draw a 6-membered ring which is aromatic, so conjugate double bond, single bond, double bond, single bond, double bond, single bond, and leave space for one heteroatom because it contains one heterocycle. So structure, write down the structure. So pause the video and write down the structure. So structure must be looking like this, and the heterocycle, um, the heteroatom in this heterocycle is nitrogen, and particularly this structure is called as a pyridine. Again, this is a trivial name of this heterocycle. So this is a structure of the pyridine. So now we have learned about a 5-membered ring, which are aromatic. Heterocycle contains 2 heteroatom, and then 6-membered, which contains 2 heteroatom and 1 heteroatom. Okay, moving on to the next category, which again contains 6-membered aromatic heterocycle, which is a 6-member aromatic heterocycle and contains 1 heteroatom. So again, draw 6-membered ring which is aromatic with 1 heterocycle. You can pause the video and you can write the structure. So it must be looking like this. Now the heteroatom particularly in this structure is nitrogen, so you can write nitrogen over here. So what is this structure? You can pause the video and write the complete the structure. So what is the name of this structure? It is what? And before writing the name, just number it. Okay, you also number it 1 2 3 4 5 and 6. So number it 1 2 3 4 5, and the structure is called as a pyridine because it contains nitrogen. Okay, we have learned this is a pyridine. Now this is the same structure which we have learned just now, okay, before this structure. So there is a little bit twist. Now have you numbered it right? 1 2 3 4 5 6, right? The numbering, this is the structure of pyrimidine with numbering. So now you're going to do add benzene ring. Actually you're going to attach a benzene ring to second and third atom. So you write structure of pyrimidine, then you attach benzene ring to the second and third atom. Okay, so pause the video and attach benzene ring to the second and third carbon of the pyrimidine. And it is called as a phenolene. So particularly benzene fused with pyrimidine is called as a, so not pyrimidine, sorry, it is pyridine. The benzene fused with pyridine is called as a phenolene. So it was a benzo fused pyridine. Now again coming to next structure, again draw 6-membered ring which is aromatic with 1 heterocycle. So you can pause the video and write the structure of 6-membered ring which is aromatic, that is conjugate double bond single bond, and it contains 1 heteroatom. So it look like this, and heteroatom is only 1, right? So the heteroatom is nitrogen. Particularly this structure is called as what? Pyridine, and you can number the structure as a 1 2 3 4 5 6. So you can pause the video and write the structure. it is a pyridine. So it look like this, and after numbering it is what, 1 2 3 4 5 6. Now here you attach benzene ring to the third and fourth atom, so to this bond, particularly to this bond. So this bond will be common between benzene ring and pyridine ring, and this structure is called as a isoquinoline. So you can pause the video and write down the structure of isoquinoline, which is fused with the pyridine. So this is a structure of isoquinoline. Okay, so if you see again, we have learned just now fused heterocycle. In particularly this structure, pyridine was fused with benzene. Okay, so pyridine, depending upon the structure, it was fused with the what, this structure is called as a pyridine, and particularly this structure is called as particularly this structure is called as a quinoline, and second structure, this structure is called as a isoquinoline. You can observe one thing, that benzene is fused with the pyridine. So this is a benzo fused pyridine because benzene is fused with the pyridine. This is an example of fused heterocycle. Okay. Now you see again one more example of benzo fused pyridine, but here two benzene rings are involved. Initially quinoline and isoquinoline, there was only one benzene ring. Now structure which you are going to see, it is fused with the two benzene ring. So draw two benzene ring apart from each other, leaving some distance between two rings, and number it. Okay, number both the rings, 1 2 3 4 1 2 3 4 5 6, like this. Okay, so this is a benzene ring. Now number it, 1 2 3 4 5 6 and 1 2 3 4 5 6. You can pause the video and you can write the structures and number it. So after numbering, it look like this. Okay, structure 1 and structure 2. Now what we are going to do, we are going to connect first carbon with fifth carbon. We are going to connect first carbon, fifth carbon with carbon, and we are going to connect fourth carbon with second carbon, fourth carbon with second carbon, and connecting atom is nitrogen. Okay, and the structure which you get, it is a acridine. Okay, so you can pause the video and you can write down the structure. That is a acridine. So this is a structure of acridine. So you have learned all the categories at 5-member ring with 2 heteroatom, 6-member ring with 2 heteroatom and 1 heteroatom. Then you have also learned benzo fuse heterocycles, right? So here it is a overview of benzo fuse structure. Benzo fuse structure are what? Fusion of benzene and pyridine. Benzene and pyridine gives quinoline. Benzene and pyridine, when fused with third and fourth atom, gives isoquinoline, and when two benzene rings are fused with the pyridine, it gives rise to the structure acridine. Okay, now again let's have a overview of the structures. These are the five membered ring azoles, right? Azoles, ol for five membered ring unsaturated. These are what? Five membered ring which contains two heteroatom. This is 1,2 azole, this is 1,3 azole, and both the structure contains the same heteroatom but positioning is different. This is 1,2 and this is 1,3. So pyrazole and imidazole, both the names are what? Trivial names. These are the structures, again five membered ring, which are these two are 1,3 azole. The heteroatoms at the first and third carbon, first and third atom. Here again heteroatoms are at the first and third atom, whereas isoxazole heteroatom is at first and second carbon. Now if you see numbering of all the heteroatoms or all the azoles, 1,3 azole, 1,2 azole, numbering starts from the nitrogen, but here in case of isoxazole it is a 1,2 azole. In case of oxazole it is 1,3 azole. So next category is six membered aromatic with one heterocycle, which is a pyridine, and when pyridine fused with the benzene you get a quinoline and isoquinoline. When pyridine fused with the two benzene ring you get a structure that is a acridine. And last category is what? Six membered ring with the two heteroatoms. Okay, 1,3 azine, it is a pyrimidine. So I would like to congratulate you that you have learned all these difficult structures very easy way. So congratulations and thank you so much for listening listening patiently with me. Have a good day. Thank you.